Hello, my name is Evis Kamangazula. In this video, we're going to discuss about gas pressure. So, the following are our learning contents, whereby by the end of this video, you need to know how to define gas pressure, causes of gas pressure, factors that affect gas pressure, effects of temperature on the molecular speed, and at the end, we're going to see absolute zero temperature. Now let's see by definition what is gas pressure. Gas pressure, this refers to the pressure that is exerted by the gas molecules on the walls of a container. So whenever gas particles are applying, they are hitting the wall of a container, they applies force. And then force manager ikapangidwa divide ndi area ya malo amene apangidwa contact ndi gas particles aja amapangapo pressure. So this pressure that is created by gas particles nimene machedwa gas pressure. So we are saying gas molecules hit the wall of the container and creates outward force. So whenever these gas particles hit the walls of a container, they create an outward force. So we are saying from kinetic theory of matter, gas molecules are in continuous motion and constantly colliding with each other. Tikakumbutsana about kinetic theory of matter, tinafotokozera nozoti kuti maparticles am gases amakhala kuyenda and akamayenda amakhala kugundana wina ndi nzake. So whenever these particles collide to each other, they do gain like an amplitude, they do gain a momentum whereby they move at high speed and hit the walls of a container, and at the end creating a gas pressure. Now let's see causes of gas pressure. So we're saying pressure is equal to force over area. Kuti mukwanitse kupeza pressure mafunika pakhalepo force komanso area. So gas pressure is caused when gas molecules applies force on the walls of a container at a particular area. So whenever these gas molecules or gas particles, they are exerting a force on the walls of a container, they do create a gas pressure. Chifukwa the force they are exerting ikapangidwa divide ndi that particular area imene pangidwa contacted imakhala apangapo pressure, which is called gas pressure. So when gas particles collide each other and hit the wall of a container, they apply a pressure on the container. So ndaninakala unozoti gas particles wakagundana wina ndi nzake amapitano akagundana kena koma akaomba mukoma la container yawo imene alija. So when they are hitting the walls of a container, the pamene amapezeka unoti they are exerting a force whereby at the end akupanga apply pressure ma walls of a container. From there, let's see factors that affect gas pressure. So we have number one, number of particles in a container. The number of particles, or we should say the number of gas particles in a container, imapanga affect gas pressure more than. So we're saying increase in number of particles results in increase of gas pressure. Mwakaonezo ni mulini ma particles ambiri, ma gas particles ambiri mu container. Ndoti pressure so imene tapangidwa apply ikhala yambiri. Chifukwa chani? It's because whenever there are a lot of gas particles, it means these gas particles, they apply or they exert more forces on the walls of a container. Pamene force yochuluka ikupangidwa exert mu walls ya container muja, ndikuti area imakhala constant, whereby when you divide that more force with a constant area imakhala kuti mukupeza pressure yochuluka. That's why when you have a lot of gas particles, you're also having an increase in gas pressure, whereby when you have less gas particles in the container, the gas pressure will decrease. For the gas particles akakhala ochepa, ndoti pressure imene zipangidwa exert ma walls muja ikhala so yochepa. Factor number 2, the temperature of the gases. Kuti ma gases atom ali ndi temperature yorani. So we are saying increase in temperature results in increase of gas pressure. Kuti temperature ma gas particles ija kala yakula, ndiye kuti gas pressure so imakhala yakula. The reason is whenever you are increasing the temperature of the gases gain kinetic energy, thereby they move fast. Akangopanga gain kinetic energy, amapeza kuti ayamba kuyenda mwachangu. By the time they are moving fast, the pamene amapeza kuti they are hitting the walls of a container ndi mphamvu. Pamene akupanga hit the wall of a container ndi mphamvu, ndoti akupanga so exert force yochuluka. Pamene akupanga exert force yochuluka, ndoti akupanga so apply pressure yochuluka. That's why whenever you are increasing temperature, the gas pressure also increases. And in vice versa, mukamapanga degrees, when the temperature of a gas particle is decreasing, ndekuti gas pressure so ipanga yani ipanga so decrease. Chifukwa choneza kuti mukamapanga decrease temperature, ma gas particles aja amapanga lose kinetic energy, whereby when they are losing kinetic energy amaenda pang'ono pang'ono. Pamene akuyenda pang'ono pang'ono ndoti apanga apply force yochepa m'mauzo of a container. When they are applying less force ndoti apanga so create pressure so yochepa. So those are two factors that affect gas pressure, that is number of particles and temperature of gases. Now let's see effects of temperature on molecular speed. How does the temperature affect the molecular speed of the particles? When we say molecular speed, this is how the particles are moving. At what speed does these particles are moving? So temperature imapanga affect molecular speed. That is, remember, particles of fluids or solids are always moving randomly or vibrate about fixed position. Tukungokumbutsana, ma particles am liquids kapena mu solids amaenda kapena amapanga vibrate at fixed what? At a fixed position. So increase in temperature increases the motion of particles or molecules. Whenever you have increased a temperature of those molecules or particles, you need to know that the speed of those particles will also what? Will also move. So the question can be why? So why does the particles molecular speed, the speed of the particles or molecules increases when you have increased the temperature? This is the reason. The reason is whenever you are increasing the temperature, these particles gain kinetic energy. So kinetic energy is the energy of movement. Ndiyo kayabanga gain kinetic energy. Ma particles are jama imba kuenda mwachangu. Pamina kuenda mwachangu ndio mapanga. So you know when they are moving fast, it means if it is in gases they will collide, they will be colliding. They will increase in temperature also increases the molecular speed. So that is the effect of temperature. So in another hand, we are saying on cooling, molecules or particles lose kinetic energy, hence reduces the average molecular speed. Pamene temperature cooling ndio temperature ikutsika. Pamene temperature ikutsika, ma particles aja kapena ma molecules aja amapanga lose kinetic energy. Pamene apanga lose kinetic energy amayamba kuyenda pang'ono pang'ono. That's why hence reduces the average molecular speed. So in conclusion, we can say increase in temperature increases the molecular speed, and decrease in temperature decreases the molecular speed as well. Temperature results in change of state of matter. We already know that my state of matter amasintha kuchoka ku solid kupita ku liquid, kuchoka ku liquid kupita ku gas, kuchoka ku gas kupita ku liquid in the different processes as follows. Melting, that is the process of whereby a solid is converted into a liquid. Evaporation, a process whereby a liquid is converted into a gas. Freezing, the process whereby a liquid is converted back into a solid. And condensation, the process whereby gases are converted back into the liquids. So zimezi zikuti ziteke zimatengera ku effect ya yani, effect ya temperature. From there, let's see absolute zero temperature. What is absolute zero temperature? So this refers to the temperature at which the molecules of a gas has kinetic and zero volume. Whenever a gas has a kinetic energy, they have kinetic energy but zero volume, the temperature which is giving this zero volume and that kinetic energy, temperature meaning imachedwa zero temperature. So absolute zero temperature, this is the temperature at which the molecules of gas has kinetic energy and zero volume. So it is estimated as negative 273 degrees Celsius, which corresponds to 0 kelvins when we are considering Kelvin scale. So absolute zero temperature imakauri in the negative 273 degrees Celsius kapena 0 Kelvin. So we are saying gases condenses to liquid or solids at temperature higher than absolute zero. Gases condenses to liquid. A gas will do condense to a liquid when the temperature is greater than absolute zero. Ungokhaza temperature sina dutsa absolute zero ndoti ma gases isanga vile ku liquid. The same as liquids, I should say the solids cannot be converted into liquids if the temperature sina dutsa absolute zero. So this absolute zero, it should be there should be a higher temperature than absolute zero for a gases to condense into a liquid. Ndikuweza mukuveteta and you are following. From there, I have an exercise for you, where question number 1 is saying explain using kinetic theory why ink dropped in warm water spreads faster compared to when it dropped in cold water. Mufotokoze kuti chifukwa yani ink mukayika m'madzi amene alo oti wotentha imapanga speed mwachangu kuposa mukayika madzi ozizira. Explain the effect of temperature on gas pressure. Define the absolute temperature. Explain why air bubbles in boiling water moves faster than in warm water. That is an exercise. Mwesera kulemba panoka ngati mungafuna zoti ndione ndoti you send it to me. Thank you for your attention.